Introduction to electric current theory. What is electric current? Electric current is defined as a stream of charged particles, such as electrons or ions, moving through an electrical conductor. It is the flow rate of electric charge through a conducting medium with respect to time. Electric current is expressed in circuit diagrams or formulas using the symbol capital I. The unit for current is ampere or amp. This is represented by capital A. The expression displayed shows the relationship between current, charge, and time. An electric current flows when electrons move through a conductor, such as a metal wire. Electricity passes through metallic conductors as a flow of negatively charged electrons. In metallic conductors, the electrons are free to move from one atom to another. We call them a sea of delocalized electrons. Please see a crude representation in the animation on the screen. Current was originally defined as the flow of charge from positive to negative. Scientists later discovered that current is actually the flow of negatively charged electrons from negative to positive. A stream of charged particles flowing through an electric conductor is known as an electric current. The moving charged particles, also called carriers, which may be electrons, holes, ions, etc. The flow of current depends on the conductive medium. For example, in the conductor, the flow of current is due to electrons. In semiconductors, the flow of current is due to electrons or holes. In an electrolyte, the flow of current is due to ions. And in plasma, an ionized gas, the flow of current is due to ions and electrons. Alternating and direct current. Alternating current, AC, and direct current, DC, are two forms of electric current that are used each with its own advantages and disadvantages. Deciding AC versus DC depends on the application and properties of AC and DC. One of the major distinctions in the type of current flow in a circuit is whether the current is alternating current, AC, or direct current, DC. AC and DC electricity are both widely used in electrical and electronic circuits, each being useful for different purposes. Both AC and DC have their own characteristics and provide different advantages that can be used in different situations. Based on flow of charge, the electric current is classified into two types, that is, alternating current, AC, and direct current, DC. Let us first consider alternating current. Alternating current, AC, is an electric current which periodically reverses direction and changes its magnitude continuously with time. Alternating current starts from zero, rises to a maximum, decreases to zero, then reverses and reaches a maximum in the opposite direction, then again returns to the original value and repeats this cycle. The types of alternating current waveforms may be sinusoidal, square, triangular, sawtooth, etc. That said, in most electrical circuits, the typical waveform of alternating current is a sine wave. A typical sine wave that you might see as an alternating current is shown by the left-hand side animation on the screen. AC electric power is widely used in industrial and residential applications. Direct current, DC, is an electric current that is unidirectional, so the flow of charge is always in the same direction. As opposed to the alternating current, the direction and amperage of direction current do not change. It is used in many household electronics and in all devices that use batteries. As DC flows only in one direction, a waveform of direct current is shown in the image on the right-hand side of your screen with a waveform of an alternating current below it for comparison. DC can be generated by batteries, solar cells, fuel cells, thermocouples, etc. An alternating current can be converted to direct current by using a rectifier. Direct electric power is generally used in low voltage applications. Most electronic circuits need a DC power supply. Alternating current versus direct current. In many areas, there can be a decision to be made of AC versus DC, and which form of supply is best for a given application. Alternating current, AC, and direct current, DC, both have their advantages and disadvantages, but this means that there is a choice to select the best option for any given use or application. Alternating current is generally used for power distribution, which is why the mains sockets in our homes and at work provide an alternating current to power whatever is needed. But direct current, DC, is more widely used for the electronics boards themselves and for many other applications. Both alternating and direct current supplies are widely used across the electrical and electronic industries, each in their own areas of benefit. Both AC and DC are able to provide electrical power transfer, but with slightly different benefits.